Students, let's discuss measurement of charge of electron. Charge of electron was measured by a scientist named Millikan, and his experiment is known as Millikan's oil drop experiment. This experiment was performed in 1909. Let's discuss the construction. It consists of a metallic chamber. This is a metallic chamber, and this metallic chamber has two chambers in it. Two parallel electrodes A and A1 is present in this metallic chamber. These electrodes are connected to a battery. These electrodes are connected to an electricity. The electricity generates an electric field of strength E between these two electrodes. One electrode is a charged metal plate which is positively charged, and the other is a charged metal plate which is negatively charged. The upper electrode has a hole in it. The upper chamber is filled with air, and the pressure of the air is adjusted with the help of vacuum pump. An arc lamp is used. This lamp is used to illuminate the space which is present between these two electrodes. So students, we can see that a microscope is also there. This microscope is used to view what is happening in between the electrodes. Students, let's study the working. This is an atomizer. The atomizer is filled with oil. When you press the atomizer, it creates a fine spray of oil droplets. A fine spray of oil droplets is created by atomizer. Some of these droplets enter into the hole which is present in the first electrode. After some time, the hole is closed. This hole is closed. The droplets fall under the action of gravity, and this oil droplet has a velocity v1, and this velocity is directly proportional to the weight of the droplet, and we know that weight is equal to mass multiplied by gravity. So the velocity of the oil droplet is directly proportional to mg, where m is the mass of the droplet and g is the acceleration due to gravity. The droplets fall under the action of gravity. Then we can also see a source of X-rays. The purpose of X-rays is to ionize the air in between the two electrodes. The X-rays ionize the gas which is present in between these two electrodes. When the X-rays strike on the gas particles, they knock out electrons from the gas, and the gas is converted into a positively charged ion. And the oil droplets that we can see over here, these oil droplets pick up electrons and they become negatively charged. Now, the electrodes A and A1 are connected to a battery. This battery generates an electric field of strength E. Now the oil droplet which is negatively charged moves up with velocity v2. This oil droplet is now moving against the force of gravity with the velocity v2, and this velocity v2 depends upon the strength of the electrical field E, and this velocity v2 depends upon the charge which is present on the oil droplet. If the charge present on the oil droplet is greater, then the velocity v2 will be greater. The oil droplet will move with a greater velocity towards the upward direction, and if the strength of the electric field will be greater, then also the velocity of the oil droplet will be greater. So the velocity v2 is directly proportional to the strength of the electric field that is created between these two electrodes and the charge which is present on the oil droplet. Oil droplets can pick one electron, it can pick two electrons, or it can pick more than two electrons. And when the oil droplets pick more electrons, then the charge on the oil droplet becomes greater. So the velocity depends upon the charge which is present on the oil droplet. If the oil droplet carries a greater negative charge, then the velocity will be greater. And also if the strength of the electric field is greater, then also the velocity is greater. So we can say that the velocity v2 is directly proportional to the strength of the electric field and the charge which is present on the droplet, and this oil droplet is moving against the force of gravity. That is why minus mg is written in this equation, where E is the charge on the droplet, capital E is the strength of the electric field, and mg is the weight of the droplet. Yes friends, I hope the experiment is clear to you. When the electric field was off, the oil droplet was moving in the downward direction under the force of gravity with the velocity v1. But when the electric field was on, when the electricity was applied and the electric field was created, and this electric field is of strength E, then the oil droplets started moving with the velocity v2 in the upward direction. Why the oil droplet is moving in the upward direction? Because this oil droplet is moving towards a positively charged metallic plate, and this velocity v2 depends upon the strength of the electric field E. Greater the strength of the electric field E, greater will be the velocity, and this velocity also depends upon the charge which is present on the oil droplet. If the oil droplet carries a greater charge, then it will move with a greater velocity towards the positively charged metallic plate. Now students, this is equation 2 and this is equation 1. We will divide equation 1 by equation 2 and we will get this equation number 3. Now we know that v1 is velocity v1 is velocity 1, v2 is velocity 2, g is the acceleration due to gravity, capital E is the strength of electric field, small e is the charge on the oil droplet, and m is the mass of the oil droplet. Now how to determine the mass of the oil droplet? The strength of electric field is adjusted in such a way that the droplet becomes standstill. The droplet do not move, and under this condition the mass of the droplet was determined by Millikan. Now what was the result? If we know the value of v1, v2, strength of electric field E, acceleration due to gravity, and mass, then the charge, that is small e, on the droplet can be determined by using this equation. So when the charge was determined, it was calculated to be 1.6022 into 10 raised to power minus 19 coulomb. This is the charge present on one electron. Yes friends, so let's determine the mass of an electron. Students, now we know that the value of charge to mass ratio of electron is 1.7588 into 10 to the power 11 coulombs per kg. The value of charge of electron is 1.6022 into 10 to the power minus 19 coulomb. We will insert the value of charge in this equation. Now E by m is equal to 1.7588 into 10 to the power 11 coulombs. So what is the value of E? What is the value of charge? The value of charge is 1.6022 into 10 to the power minus 19 coulomb over m. We have to find out the value of m is equal to E by m is equal to 1.7588 into 10 to the power 11 coulomb per kg divided by 1. We have written 1 in the denominator. So what we will do? We will cross multiply. Mass is multiplied by this value, and 1.6022 into 10 to the power minus 19 is multiplied by 1. So m multiplied by 1.7588 into 10 raised power 11 coulomb per kg, that is equal to 1.6022 into 10 raised power 19 coulomb multiplied by 1. So in this equation, the value of 1.7588 into 10 raised power 11 coulomb per kg is multiplied by m. When we will move this value towards the right side, then it will come in the denominator. So in this way we will calculate the mass of electron. Coulomb and coulomb will get cancelled. When kg is in the denominator, then it has a power of -1. When kg is taken or written in the numerator, then its value becomes +1. So we have calculated the mass of electron, and the mass of electron is 9.1095 into 10 raised power -31 kg. Students, let's solve example 2.1. The question is, how much heavier is hydrogen atom as compared to an electron? The mass of hydrogen atom is 1.67 into 10 raised to power -27 kilogram. We have calculated the mass of electron, and that is 9.11 into 10 raised to power -31 kg. So we will compare both the masses. Mass of hydrogen will be written in the numerator and mass of electron will be written in the denominator. So mass of hydrogen is 1.67 into 10 raised to power -27 kg per hydrogen atom, means mass of one hydrogen atom, and mass of electron is 9.11 into 10 raised to power -31 kg per one electron, that is mass of one electron. So the answer is 1833. The hydrogen atom is 1833 times heavier than electron. Hence hydrogen atom is 1833 times heavier than an electron. Students, your assignment is review question number 2 part 1. How mass of electron can be calculated from charge to mass ratio and charge. Question number 2 part 13. You have to this question is related to the deflection of cathode rays. The diagram is given to you and you have to answer the questions by looking at the diagram. Question number 3. How much heavier is hydrogen atom as compared to an electron? Thank you, students, and stay blessed.